So taking a look at these four equations that you see up here, some of them hopefully look somewhat doable. You might have ideas about how you could solve a lot of these already. However, there's also going to be some here where you don't know how to solve them yet. And so what we're going to be doing today is seeing how we can actually solve each of these different types of equations, actually using the same method. And it's going to be a method that we then can expand to all sorts of other situations that can be even more complicated than these are. And so, to start with, I just want you to start with a little bit of basic graphing. That's why you got the graphing grids there. So, in order to graph this, we're graphing y equals 2. Now, sometimes this throws people off, which is why I'm starting with it here. The first way that I normally talk about graphing something like this is I ask you to kind of look for where is a point on your graphing grid where y equals 2. So do you see a point where y equals 2 there? At this point, almost everybody right now is looking at this point when I say that. However, what's another point, a different point, where y equals 2? Well, notice x can be anything, right? Like if x was 1, y could still be 2. Or x could be 10, and y would still be 2. Or of course x could be negative 10, and y would still be 2. If I can get the words right. And so you'll notice then, every point along a horizontal line here has y equaling 2. So this is the graph where y equals 2. If you haven't yet drawn it in, draw it in. All right, and so if we're going to graph now this, y equals a negative 6, you're basically going down to negative 6, and you're drawing the horizontal line that goes through there. So there is our y equals negative 6. These horizontal line graphs are actually going to come up a lot in the work that we're doing today. But before we get into it, I asked you how we could solve some of those equations, right? Here we have x minus 3 equals 2. You could already solve this algebraically, right? What would we do first? We'd add 3, yeah. So add 3 to both sides. So we add 3, and you end up with x equals 5. No problem, right? You can actually do that exact same thing, get that exact same answer, by graphing. And that's the process that we're going to learn today and what we're going to see today. And I'm starting you off with an easy one that yes, you could solve otherwise, but so that the graph's a little bit easier to look at and work with as we go. All right, so if I'm going to graph this and solve it by graphing, we can't necessarily graph this just as you look at it, but what we can do is actually split it up into two different equations. Because really I have y equals x minus 3, and I have y equals 2 here. And so that's what I'm actually going to graph. I'm going to graph y equals x minus 3 and y equals 2 as two separate equations on the same set of axes. All right, and so to graph them, first up, the y equals x minus 3. Well, notice the minus 3 hanging on the end. That's going to move it down 3. And then it's our normal y equals x graph, so that means we're going up 1 over 1. And we're just continuing that to get a line. And so you draw those points in. Yes, extend them all the way out. Use a straight edge, please, to draw in your graph that goes through them. You always want to make sure to get out to the edges. Actually plot the points out as far as you can. In this case, that's going to be the point that's here and the point that is here. Because the further away those points are from each other, the easier it is to be accurate with your straight edge as you draw the line through them. And then we're also going to be graphing the line y equals 2. We already know what that one looks like, right? That's what we did at the start of class. We graphed y equals 2. And so that's where we go up to where y is 2, and we just draw in the horizontal line. And so this is what our two graphs should be looking like. Make sure you have both down and correct on your paper. Now that we got the graphs, we're not actually done with this problem. Because we made the graphs, but the graphs are actually just the work we do. It's kind of like when we added 3 to both sides. It's just the work we do to be able to figure out what x equals. but we still do need to figure out what x actually equals, because it actually said solve for x. And so my answer then is going to have to be x equals something. That something is where both of those lines equal the same thing. Or in other words, where do they cross? What is the x-coordinate of that point? It is at 5. And so our final answer then is that x equals 5. You wrote down the original equations, then you graphed them. Write this answer now below your graphing grid or next to it, that x equals 5 here, so that as you look back at it, you remember. All right, so having gone through all that, then you might be wondering, well, why didn't we just do it algebraically then? Wouldn't it be faster just to have added 3 to both sides? Well, yes, but what if I then give you this? How would you solve this? Well, algebraically speaking, we haven't done anything like this. Technically speaking, it is possible, but it's very challenging to do at this point without saying some of the methods that are involved with solving a square root equation. However, if we use the method we just saw, we can solve this same equation by graphing. Now, in order to do this, remember I take the two sides of the equation as separate equations unto themselves. So I'm going to take that square root of x plus 2 plus 4. That's one equation. It's y equals that. Notice, by doing that, I made it into something I can graph. And the right side, the equals 7, that's just y equals 7. Hence why we started the class practicing those horizontal line graphs, because we needed to see, because it's going to keep coming up a lot. All right, so now we can go ahead and graph these. For the first one, what does the plus 2 do to my graph? It shifts it. Which way? Up, down, left, or right? Yep, it goes left. And so this is a great reminder, though, too. Write those arrows above it. It helps you to remember which way the thing is moving, rather than trying to keep track of everything and potentially lose something. What about the plus 4? It's hanging on the end, so we know it's up and down, but which is it? Is it up or is it down? It is up. Absolutely. Good. And so that tells me that to make this, I'm going to go left 2, up 4, and plot my first point right there. Having done that, I now can make my square root graph, because this is the same as all the other square root graphs we've ever made, right? And so I know from that starting point, I go over 1, up 1. I'm also then going to go over 4, up 2 from the starting point. And then from the starting point, I go over 9 and up 3. And then I run out of graphing grid. So I go ahead and draw in the curve that goes through those points. Yes, make sure that those points are plotted neatly and clearly, because sometimes you want to be able to look back and tell, hey, it actually went through that point. Like you'll notice how I drew my curve in through those. You notice I got a little sloppy. You'll notice it looks like the curve is actually going through that point, but it's not. I can tell by the dots that it's supposed to be going through this, and there's my sloppiness that's making it look like that. And hence why you want to make sure those points are nice and clear, easy to read. Also partly why in the last unit we made such a big deal of making sure that you knew exactly where each of those points go. It's going to let you solve these. All right, the second part, we graph the y equals 7. Of course, that's going to be a horizontal line that's up at 7. So go ahead and draw that in. And once we have our graphs drawn, you then can use them to solve this. What we could not solve algebraically, you can now solve graphically, because we're still just looking to see where do they intersect? Where do they equal the exact same thing? Because notice, I'm looking to see where the two are equal to each other. And so, where they cross, that is at x equals, remember I'm only interested in the x-coordinate. What does x equal there? 7. Yep. Because if I follow that down, it's going to be right here, which is over 7. Having seen those previous problems, I think you got the idea. So go ahead and solve this equation for x, please, by graphing. And so as you're working on it, remember that we start by splitting it up into those two equations. So the first one we're graphing is just the y equals -1. That's the left side. Then I'm going to graph y equals the right side, so y equals that absolute value. The absolute value bars tell us what's the shape of the graph going to be? Yeah, it's a V. That's one we got to know, right? And so when we actually plot everything, this is what we're looking at. All right, so now that I have the graph, I now need to talk solutions. Because remember, the graph is just the work we do to get to the solutions. And so I still need to be able to say, what does x equal? But you'll notice in this case, there's actually two different times when the two graphs cross. Well, that means we use both of them. And so there's actually going to be two different solutions. 1 and 2. So I give both those x coordinates. So the first one, and I say first, it doesn't actually matter which one you say first, but the leftmost one, how about that? The one on the left is at -1. The one on the right is over at 7. And so those are our solutions. X equals a -1 and 7. A little side note here. The way I wrote the answer there is exactly what I want to see on your paper. What I do not want to see is parentheses around those numbers. Because as soon as you put parentheses around it, you're saying that this is x and this is y. We just want that to be a list of numbers, and so no parentheses. Of those 4 problems I showed you at the start, this is the last of those. So please solve this system. All right, and then we go and we graph this one. And again, we set the left side, y equals to that, and the right side, we go y equals to that. So that's how we get our two equations here, and then we're graphing them. All right, so for that first one, again, it's good to write those arrows in. That x plus 1 is going to move it left 1. The -2, because it's hanging on the end, that goes down 2. So I'm going to go left 1, down 2 to get to my first point. Once we've done that, then it's just a matter of making the same old x squared graph that we're used to making. The one that we've been doing for about a month now. Remember that x squared? That's going to be that U-shaped graph. All the points on there. Let's make sure you got a reminder about where they all go. So to get my first point, I go over 1, up 1 on both sides. That sure happens a lot, doesn't it? But from there, this is where things change. My next point, from my starting point, remember I'm counting from the first point, over 2, up 4. And it's been a while since I mentioned why that is. Remind you, the reason why it's over 2 and up 4 from the starting point is because 2 squared, and this is the next squared graph, 2 squared is 4. And so that's why when I go over 3, I go up 9. Because 3 squared is 9. And then we're out of moves from there. We can't go up any higher after that, so we can go ahead and draw the U-shaped graph in from there. And of course the y equals 7, that'll be a horizontal line up at 7. And so this is the graph you should be looking at. And again, by plotting those points and making those points on your graph nice and big and easy to see, if for some reason your curve didn't look like it was going right through that point, you'd still see those dots there, and you'd be able to tell, no, it should be going through those, and so yes, it is in fact going through those points as my solution. And so, final step though, you actually need to write this part down, or all you're doing is the work without actually giving an answer. Down at the bottom of your graph, write what x equals. And so for the first point, that's going to be x equals -4. And for the second point, there it looks like x is a +2. Remember, no parentheses on those.